I am taking a deeper dive into a more accurate setup on the 33. I have it set up in my milling machine, and I'm using an indicator to check the top surface of the tub in relation to the top of the curved turn fin, and also for checking the prop shaft angle. The reason for this is with this Laner motor and my SMC lipos, I have a crazy amount of power as I get closer to loosening up the 33. It occurred to me when I blew it off the water last time and I wrecked the V3 sponsons that do I really know, even with a digital pitch gauge, the angle that I have. And the reason I say that is when I zeroed out on the tub, I am setting this on the entire surface, the length, flat on the length of the top of the tub. I am lightly setting it on the top of the curved turn fin and just touching down my finger, and it's only catching the width of the curved turn fin as far as getting an accurate reading on that surface. And when I come back to check the prop shaft angle, I am only engaging a very short length of the flat surface on top of that strut. So it makes sense that this would be more accurate over a longer surface. You get some differences of seating it as far as seating it and reading an angle when you hang it off the back of the prop shaft or the strut and just catching this edge, which is just catching like one corner of the pitch gauge instead of the full width of the bottom surface like you do when you set it down here. And yes, I am finding some slight differences. So with an indicator, you have a very precise low amount of pressure, just the spring pressure of that needle reading the surface. With the indicator, I have this lightly snug down in my vise, so I've kind of bumped it around and I have it zeroed out. Now bear in mind, this is checking it over the surface of wood. So I'm checking it about the distance of the base of the indicator. And I'm also checking it right above the sides in case the lips are a little bit warped. So this is telling me also how accurate the laser cut is. Here's 0. And if I wind the table over here, coming across that notch, it'll dip about 3 thou, 2.5, 3 thou, and then come back up to pretty much 0. Like that is really good as far as accurately setting up this tub when we're talking about running an indicator on wood. So now I have the needle zeroed out on top of the curved turn fin. I will back it up and you'll see it come up the radius till it gets to 0. And what I am doing is I have zeroed out my table. So I'm going to move it. Every 2 turns is 200 thou. So I'm going to move it 2 inches exactly across the top of that surface. I'll count the turns in twos. 2, 4, 6, 8, 1 inch, 2, 4, 6, 8. Come back to 0. Whoop, went a little bit past. So there it is, exactly 2 inches. And my indicator reading looks to me like 3 6/10. The long lines are 1 thou, and it's ½ thou in between. So looks like 2, 3 6/10 of a thousandth of an inch. So I'll do the calculation on what that angle is exactly. So a rise of 0.0036, a little over 3.5 thou over 2 inches, works out to be exactly positive 1/10 of a degree, as you can see by this screenshot right here. And here's another interesting thing to note. How accurate is this indicator? So when I rest my hand on here, when I take the digital pitch gauge and I rest it lightly, just catching it on the edge. Watch when I just touch down on my finger. I'm going to just touch this lightly. See how accurate that indicator is? I am barely touching it. So that is my true reading. So now let's look at the reading I was getting with the digital pitch gauge. It's actually pretty good on this measurement. As far as the curved turn fin measurement goes, here it is set at 0. Just to show you, if I raise it up, move it, set it back down, lightly hold my finger on it, and then if I come over here, set it on there and just touch down with my finger, so I'm getting 1/10 blinking 2. But I know the indicator reading is exactly positive, so there's raising the front up. Right, it's a positive. It's positive 1/10 of a degree setting on my curved turn fin. Now I have the indicator set up on the strut to check the prop shaft angle, and I can move 3/4 of an inch across here. So I have this zeroed out, and I'll count the turns, and we'll watch the needle for the rise on this strut. 2, 4, 6, 7, 50. And that looks like 8/10. And I am all the way across the strut. So checking that prop shaft angle. So that is slightly over positive 1/2 degree. It's 0.06, as you can see by this screenshot here. So here is the biggest difference between measuring with a digital pitch gauge. Here it is zeroed out. And if I come over here and hold this on here, I have to squeeze it flat on that surface, kind of level it, and just kind of work it back and forth a little. And it looks to me like I am coming up with 2/10 of a degree. Blinking 3. So what exactly is that? So that is exactly why I went to maybe a little bit of a deep dive, but checking it with this indicator across these surfaces. So what I am seeing is pretty accurate reading all the way across the curved turn fin, at 2 inches versus the distance across this base. Like this repeats pretty good when I set it on top of the tub. This repeats pretty good with light pressure. But taking this base and only contacting this much of it across the strut is not accurate enough way to check it. So that tells me the other day when I blew it off the water and wrecked the V2 sponsons, I had this set at 0, or so I thought. It was actually positive somewhere between 1.5 and 2/10 of a degree. And using the trigonometry table, indicator drop, moving exactly the distance so I can put the numbers into the calculator, the right angle calculator. Now I know. So I said I was probably a little overconfident when I loosen it up based on my previous runs. But that's what I mean by accurate setup. I went through the transition, pushed it somewhat, went through the transition. I think the front was fine. I had it at 2/10. Now I'm dropping it down to 1/10, positive 1/10 from positive 2/10. I'm going to run it there. I think the front's fine, but with this much power, with the Laner motor and these SMC lipos, the Castle XLX2, heavy duty wires, connectors, I am getting a lot of power coming to this prop, and this is a strong prop. And that's what I mean by loosen the front up from in the back. When that, here is your center mass, here is where you're thrusting. You're thrusting underneath it. I think with enough power, you can have the prop basically walk under the tub and blow off. So, as I've said before, I like, it's more dependable, repeatable, gives you more confidence, where the setting on a curved turn fin is loosen up the front. The prop shaft angle along with your rake angle is given a certain amount of lift in the back, but they're lifting together and it's running straight and level. So we'll get it back out and run it with this setting with, I think, a whole lot more confidence. So yeah, that's a real deep dive, but kind of some pretty interesting findings. I was pretty confident in what I called accurately setting up my settings, and setting it up with here on that little bit of surface, in my mind, was not accurate enough. And I certainly understand why for some people this is a little bit over the top, but when I get some flat water, waiting on weather right now, it's been a little breezy, I certainly feel like I'll go out there and run it again with a lot more confidence.